Okay, so in this project, we will be usually talking about carbon filters. We'll talk about reverse osmosis a little bit, but all of our tests are done with carbon filters. So just get that. We'll also the chemicals we will be testing for would be we'll be testing for chlorine. Will be pH, cyanuric acid, iron, lead, copper, aluminum, mercury, sulfate, total chlorine, free chlorine, bromine, nitrate, nitrite, fluoride, hardness, and total alkalinity. Those are the chemicals we'll be testing for. We'll show you how we do the testing, show you what we use to do the testing. Now I'm going to tell you about activated carbon and why they call a carbon filter a carbon filter. So, it's called a carbon filter because they use activated carbon inside, which is usually actually made from burnt coconut husks. It can be made from other burnt woods, but usually burnt coconut husks. So what they do is they put that inside the filter in tiny bits, but much bigger than chemicals like chlorine and stuff like that. And then over time, when the water's flowing through to go into your cup or whatever, your soup or something, all those chemicals will catch on the activated carbon while going through. But that's how the carbon filter works. But over time, where those chemicals catch, there's no more room for other chemicals to fit there, and that's why your filter will start working less and less over time, because it'll just once it's halfway done, it'll hit piece of chlorine that's already there, and then it'll bounce off because it doesn't stick to chlorine doesn't stick to chlorine or something like that. So that's why you need to get new filters, and that's why they call it a carbon filter. They use activated carbon, aka burnt coconut husks. Also going to give you a couple takeaway home messages. So after 5 months, the sink only filtered out 25% of chlorine out. So that was after. So it doesn't do it as it rapidly decreases in amount it takes out. After 1 week, sink filter removes 60 to 70% of chlorine. And fridge filter and sink filter had 0 chlorine immediately after replacement, which means when we replaced them, it just had 0 chlorine as soon as we replaced them. But next day, it had some again, very little. But as I said before, if you do a slow flow rate, it'll have 0, basically the whole life cycle of it. Okay, fridge after 1 week still had 0 chlorine. So fridge filters usually work better than sink filters. Just for I think it's this. I don't know this for sure, but this is what I think it is. They are bigger, which means I think that this means there's more activated carbon in the filter. So it just lasts longer and works better. 0 chlorine found in rainwater, pond water, bottled water, pee, and spit. The reason we did and sweat. So the reason we did pee and sweat is to figure out if the chemicals went out of your body. But they just stay in there, which is kind of a creepy fact. And so they don't go out of you. And then 7. In Sarasota, haloacidic acid is over 700 times the normal amount. That's not 7 times 700. We've also done all the tests we'll show you on PowerPoint more than once, usually more than 5 times each. So it's not like one test and that's the answer. We take the average of and then use that. Okay. So this is not the Brita filter we use for other test results of getting less chlorine on slow flow rates, but it does work the same way. You can do slow flow rates and have less chlorine. Like this is slow flow rate. Okay. And we'll do a slightly faster flow rate. And a fast flow rate. So this is a new filter we got, so there might not be too much of a difference, just because it's a newer filter. But I'll show you, this is the fast flow rate. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Worked better than last time. Solid. Okay, so this would be around I'd say a 2. There's now do this one. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should be about, I'd say, a little higher than 0.5, so you can already see a difference between sort of fast and fast flow rate. And now we'll do a slow flow rate. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That'd be a 0. 0 chlorine in here. So these are our chemical test tabs we use for multi-chemicals, like getting all these ones. Got 15 chemicals you test for. The brand is MedLab Diagnostics. So yeah, I'll show you how to do it. 2 seconds. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, keeps on going to 60, 23, 20. Here, these are, this is a bar chart. What we use bar charts for is to show you around the area where, how high your chemicals are. So, here you see, blue is, sink with no filter. Orange is sink with filter, the Brita Chrome filter. And gray is refrigerator, Ice Pure, which seems to be a pretty good brand. So here you see there's no difference in the ones and sulfate. The filter, no filter refrigerator doesn't change that. And same with hardness. Now I'll go down. And this is these ones here are some of the same measurements, but here you see the blue, which is like I said before, the sink with no filter is higher there in total chlorine, and free chlorine and bromine. it's the only place where it shows up. The other, the sink with filter and refrigerator take it totally out, and fluoride it's higher. But the other ones are the same again. But these results you see below, these ones right over here, are from us mixing a bottle of 1,000 ppm chlorine with deionized water, which this is the machine you use to get deionized water. So this is part of it, this is part of it, this is part of it. It's a big machine. So with deionized water, which is water with no other molecules or chemicals in it except for the original water molecules. It will be bad for you if you drink it. Okay, so the reason we have mixed these 1,000 ppm chlorine with deionized water is to get a calibration curve, which is what you use a calibration curve for is to get exact numbers. Like say we only have numbers here on our bottle when we compare the bottle to our test tabs, which these are our test tabs. Is we only have numbers like 0, 0.2, 0.5, 1, 2, 5, and 10. But we want to get the ones like 4 and 3 and other things like that. Humans can only guess at that, really, unless you make a calibration curve. You get concentration by how we mixed the deionized water with 1,000 ppm chlorine. We haven't talked about getting saturation, though, which is a big part of this calibration curve we're making. So here how we get what these numbers are and these colors. You can see they're similar to the other to their counterparts above. That's because we used an eyedropper, which is a little thing on PowerPoint. You can click on a color and it'll give you the saturation intensity of that color and a number, and then you can tell the intensity and saturation. This will be a short little thing here. Just show you what these just shows you different colors here. So another reason we're going to do the calibration curve is figure out what this color number this color would be in a number, or all of these colors, and it just shows you this is lighter, the fridge filter, than the sink filter. Like I said before, it just works a little better because I think it's bigger. And this is a test we'll show you later on a bar chart. And this is just our old shower filter. So these little dots over here are different measurements we took, and they ended up right here. And this is the calibration chart I've been talking about. Well, the suspense, I know. So these are supposed to go up in a straight diagonal line where this is. They're supposed to be right on there, which they're very close. And this is the problem that gives you how close it is. This is 0.9577. And the number you want it to be is a 1. So 9577 is very, very close. So this is pretty close on it. So this is concentration. But what we want to do is we want to figure out what the number is in concentration, not saturation, because we already figured out the saturation, like down here. Those are all saturations, and that would be like over here, one of those saturations. We want to figure the saturation doesn't really do anything for us. What we want to figure out is concentration. To do that, because concentration gives you an actual number, and to do that, you'd have to draw a straight line this diagonal line in the middle, and then go straight down. And that is your, where you go straight down, that is your number. That's the concentration, ppm, you have been looking for. And then, this is the problem you can use here. And you can incorporate, other, things like some of these numbers into there. And then you can get their exact saturation and then use that algorithm to go down. So these are the results we got using a calibration curve here. We showed you a bar chart earlier that had some of the same stuff, but it wasn't as exact because in this one we used the calibration curve, so it shows you more proper measurements. So here, this is the sink with a filter. 4 months after replacement. This is the same thing, also 4 months after replacement, but it's slightly different. The reason it shows slightly different is because we used the calibration curve, and that can just show you very small differences that the test tabs wouldn't be able to pick up, or we wouldn't be able to see the differences with our eye. This is the sink 1 week after replacement, and this is sink immediately after replacement. So in 1 week, it went from 0 to 3. So that's pretty, it can advance a lot in just 1 week. This is fridge filter, 7 months after replacement. So this shows you how good the fridge filter works. This is 7 months. That's like about double the sink filter's life, and it's already working better than the sink filter would at 4 months. So fridge filter works quite well. This is refrigerator 1 week after replacement. That shows you after 1 week it's still got 0 chlorine in it. And this is fridge filter immediately after replacement, which we already fridge filter immediately after replacement, and 0. Shower filter, it is, this is shower filtered, it is pretty high. And then this is shower old filter, is actually lower than the new one. This is unfiltered tap, so that's the highest one. It's got a lot of high in other chemicals too, but mainly chlorine. Bathroom sink unfiltered and shower unfiltered. So here is more results from the calibration chart. And this is this here is a time regulation that we did. Shows you the so we filled a cup of water at 9:30, a cup of water at 10:30, a cup of water at 11, and then so on till 12. Now, our experiment, what we thought was going to happen, was the chlorine was going to evaporate, but it didn't. So our hypothesis didn't work with that one. But this part here is quite interesting. So this goes along with the flow rates I was talking about. There's less chlorine. This says 173 milliliters per minute, which there means there's 100. So that means it's a very slow flow rate. If it's only 173 milliliters in a minute, and then that gives you 0 chlorine. These tests are done for chlorine, no other chemicals. And then here it shows you 568 milliliters per minute. That's a big jump. Just same filter, same sink, different flow rate, jumps up so much more. Then here you go to 1,000 milliliters per minute. It's around the same, and then same with 1,090. But then you go to 2,000 milliliters per minute. This and this. Same filter, same sink, different flow rates, big difference. All of our other filter measurements we have done have been with a Brita chrome filter, but this here is a new filter we haven't used before. It's 2 days old. It is a pure filter. It's the brand. It's not like the ice pure refrigerator. It's just pure. And it in 2 days at a low flow rate, it has 0 chlorine. A medium flow rate, it has like almost undetectable. Then high, it's got not that much. It's around a 3. So you're almost done. This is the final slide. This will just tell you some take-home messages. I'd say the major one would be run your sink filter on a slow flow rate. Then you can have 0 chlorine like almost the whole way through. If you don't want to run it on a slow flow rate, this is much more expensive. I'd say if you want to have a completely clear filter the whole time, you'd have to replace it once every 3 days. So, much cheaper is to do a slow flow rate. So, the old sink filter, as you see here, that gunk over there, close up over here, is in 1 week it accumulated all that stuff on it. And here, this is the new sink filter, pure. It has test results above that we showed you earlier on the above slide, and those are the test results for its flow rates. So when at a slow flow rate, it still has 0 chlorine. This is day 2 on it. This is the old. This is a fridge filter. I know it looks smaller than this one here, but it's actually a lot bigger. It's just shrunken. So that's why I think it works better. It's bigger. This one didn't work so well. It's supposed to be like a pitcher, but the first day it already had 3 ppm in it, which filters out a lot, but it's just comparison to this, it just doesn't work nearly as good.